Good afternoon, ladies and gentlemen. I would like to welcome you in the name of the National Széchényi Library. We are very honored and very pleased that we can welcome you in the framework of this seminar and the workshop. I would like to share with you that I'm really pleased, and the National Széchényi Library is very honored that we can host the seminar, the executive committee meeting and the board of directors meeting of CERL. So thank you very much for choosing us, and that we will be able to have this program with you. So I would like to share with you one more important thing. I'm really grateful for my colleagues who helped me to put together this program. I would like to thank you, CERL, and the colleagues, and my colleagues in the National Library. It's really important to know that it is a real challenge to put together this program. Not the professional side, but the technical side, because you will see that there is an online stream throughout YouTube. We are going to have most of the speakers online. We are going to have one speaker here, and the participants will be in the room as well. So we will do our best to have a fantastic workshop and seminar. So thank you very much for being here, and I would like to give the floor Claudia, the president of CERL. Thank you very much for being here, and the floor is yours. Thank you very much.
Well, thank you, Judith, and a warm welcome to all the participants to this hybrid workshop which we are doing today in this fantastic, not at all hybrid, but very real building. I'm extremely happy and excited to be in Budapest again. We had a lot of common projects, and now we try to sum up on this, or to open up new perspectives in talking about approaches to cross-collection searching. What a better place than Budapest to discuss this kind of issues, seeing your large collections, the collections of all your colleagues in the room, of the international membership of CERL, and of all those who are listening to us on this hybrid occasion. I'm particularly pleased to see real people in the room, and except the librarianship issues we will tackle today and the consortial issues which are beyond them, what we might also learn is what can we get from a real presence at a room altogether, and what is where we can virtually interact in a useful way. So to all of you who are listening to us and watching on the screen, I'm very unhappy not to see you, but the more happy to see all those who are here and with whom we can more directly interact and share an experience. I hope you will be active in the discussions, and I'm very thankful for all our speakers who did invest in preparing a speech, even if we listen it only on looking at the screen. That is extremely welcome, and we are glad to hear about your experiences and to share about it tomorrow after the meeting. It's also a new format of meeting because we squeezed it in 2 extremely busy office days. So we will have 2 exciting hours now and try to finish more or less in time at 5:30. And tomorrow we will start again with the seminar and then do our consortial work in place afterwards. So I wish all of you a fruitful and nice event. Thank you very much.
Also, a word of welcome from me. I'm Marion Lefferts. I'm the executive manager of CERL, and the idea of having this approaches to cross-collection research originated when we had our last meetings in Rome in autumn of last year. So you can imagine this was an active and energetic way of putting together a conference, and I'm extremely grateful to the speakers who were willing to give their words to us and take time out of their busy schedules to do the papers for us. Now, ever since the introduction of electronic resources and tools, cultural heritage institutions have been keen on creating digital infrastructures and for trans-institutional and transdisciplinary collaboration in different fields of cultural heritage. So in that essence, it's not new. We brought together specialists from a range of disciplines and backgrounds. Interdisciplinary research was a thing when I was a student in the 90s, so it's an ongoing activity, but it's given new life in recent years, supported by Europe. And what we're trying to do today is to look at examining different successful approaches to cross-collection searching, and a reflection on what has gone before, and a look ahead, what might be possible, and the types of infrastructures that we have or would need for that. I'm very happy to introduce the first speaker, Saskia Scheltjens from the Rijksmuseum in Amsterdam, who will give us a little benefit of a tour de horizon from what has gone before, and a detailed explanation of what is happening in the Rijksmuseum in this respect. So Saskia, thank you.
Thank you, Marion. Can everybody hear me? I see Marion nodding. So I'm trying to share my screen. So bear with me. Can you see my screen? Yes? I know. Yes. Now I hope you can see my full screen. I can't see you, if there's something, or if you want to ask something, please do, but speak up loud. I hear myself a little bit in echo, so I hope you don't feel that or hear that as well. If it doesn't bother you, then I'm just going to start. Is that okay, Marion?
Yeah, go ahead. This one is off, but
thanks.
This one off?
So thank you for organizing this seminar. Since I'm on the board of directors of CERL, CERL is close. I very much wanted to be there as well, but due to personal and professional reasons, I couldn't. And thank you for the library there to host this seminar as well. Marion asked me to tell a little bit about cross-collection searching, past, present, and future, but I took the liberty to also tell something about the new collection data infrastructure of the Rijksmuseum. Since I have to do that in half an hour, these are not small subjects, I'm going to rush ahead. Where do I? Yes. Being a head of a research services department within the Rijksmuseum, I'm very much confronted with not only library collections, but also object collections, archival collections, etc., and the use that researchers make of it. So I couldn't help but think first about the relationship between research and search. Closely related as they are, they serve different purposes and involve different processes within a cultural heritage context, where cross-collection search really involves more technical and logistical aspects, and cross-collection research, the intellectual and scholarly process. But I think the holistic approach that researchers take is basically what they want and need is they see all this before them. If they're lucky. This is a small portion of all the different information that's available within the Rijksmuseum about the Night Watch, where they really aren't interested what is in an archive, what is in a museum collection or a library, or what is research dated, or etc., etc. They have a basic holistic approach to paint a more complete as possible picture. Also influenced by the growing data awareness that you see in humanities research, where you see a collection as data approach. So related as they are, it's good to keep in mind that what we're doing this for is for this wealth of information and data to become available for research. The first approach to cross-collection searching, you couldn't start talking without acknowledging the manual indexing and cataloging and standardization that has started it all off, with manual card catalogs, printed indexes, and this picture is of the Marjorie Bottenheim, the first chief librarian of the Rijksmuseum Research Library, but also responsible for the first uniform description of museum objects during the middle of the 20th century. There was only limited cross-referencing possible across collections then. And what you see is that in the middle of the 20th century, you see the rise of microfilm, centralized catalogs, where there is a slow possibility to share documents across institutions. Searching was still manual, as you see in this beautiful picture, but it was limitedly possible to combine records from multiple institutions. It was only in the mid-60s, with the rise of digital databases, early metadata standards, that you see more evolutions. And of course, I couldn't help but add a picture of Henriette Avram, who developed the first MARC format, but also picture of Taco Dibbets, our current general director of the Rijksmuseum, checking out the first OPAC in the museum library at that time in the Rijksmuseum, where individual institutions digitized their catalogs, creating isolated digital collections, where metadata schemes like MARC standardized catalog records, and OPACs allowed users to search digital catalogs online, mostly one collection at a time. You also see then is early efforts to fit different types of collections into one metadata standard. I won't be the only one who remembers mythical discussions how to fit objects in a MARC record, for example. And then by the late 1990s, you see the rise of federated search systems. I would have wanted to say up until the 2000s, but interestingly enough, several of those federated search systems are still in use. For example, the virtuele catalog in Karlsruhe, where using Z3950 or SRU protocols, there's a simultaneous search across multiple catalogs that is set up with the return of separate but non-duplicated results per catalog. And made an effort to make a diagram of how this works. This is done by a non-technical nerd, so bear with me. But what you do is send one query to different collections, and what you get in return are non-duplicated search results. Usually it was very slow, easily breakable, but it was a first effort to search across collections and present what you get, and to emulate what a lot of researchers do physically, visiting all kinds of different collections. At the 2000s, what you then get is aggregated search and portals, where the Open Archive Initiatives Protocol enables data harvesting from different sources and presented in a unified interface. And I've added here examples from the DPLA, but also Europeana, of course. What you see also then are first linked data initiatives, where interconnected data uses standardized vocabularies like Dublin Core. You've got also first crosswalks between metadata formats, resulting, for example, in the Europeana data model. Also here, a diagram to make clear that there's a clear difference between a federated search and an aggregated result. And I think what we are now experiencing is more the development that we see in semantic web and linked open data, where we use knowledge graphs to connect disparate data sources from semantic relations, through semantics relations, for example, using Wikidata, Getty vocabularies, icon class, where you have entity-based searching, where concepts are used rather than keywords to bridge collections, using Sparkle endpoints to query RDF datasets to retrieve related data. And I don't give examples here because I think what Rob Sanderson will show after this presentation is a beautiful example of this effort, and where the Rijksmuseum also tried to do something similar. And I think that what we are now seeing and what we will see more and more in the future are AI enhanced and multimodal searching. I think very possibly combined with semantic search, where what you see is automatic metadata generation, enhanced entity recognition, and image and multimedia search with visual and audio recognition that is integrated with text-based metadata. And more, I suppose, than what seems plausible is personalized and contextual search as well, where AI is used to tailor search results to user contexts and preferences. And I've not really given examples here. I think we're at a moment in time where several experiments are being done, but that's what they are. The Rijksmuseum is also experimenting with and offers certain tools for users, but it's not really fundamentally incorporated as of yet somewhere. Although what I put on the screen is Google Arts and Culture initiative, who I've put very interesting, where they combine semantic initiatives together with AI enhanced searching. Next to that, you can't talk about all this without acknowledging that there's an evolution from searching simple types of collections to more integrated cross-collection searches, where historically the focus was on single collections. Admit someone. Okay. Where the focus was first on single collections or single type searches, and it became more the concept of combining different type of collections that emerges. I think that what we're now seeing is a breaking down of silos, where we try to create seamless search experiences across diverse data types and cultural heritage domains. And I've more or less chronologically put development here again on the screen. That was really quick. And I think I'll now move on to a quick description of the new collection data infrastructure that the Rijksmuseum has developed out of a similar felt need to expose more of its collections in a more diverse and rich way. I don't think I have to present the Rijksmuseum anymore, but still the National Museum of Art and History of the Netherlands, with a mission to connect people, art and history. And as an information scientist, I find the connecting bit the interesting part, where there's 1 million objects, 1.5 million books, a de facto national art library, 3 kilometers of archives, and many, many, many terabytes of research data and counting. Where there are about 2.6 million visitors on site in 2023 and 8.1 million visitors online. And one of the things that I am particularly proud of was the fact that the Rijksmuseum in 2013 and counting is an open data champion for releasing its collection data in an open way. By the same year, there was also the development of an interface that is now called the Generous Interface, which is called Rijksstudio, which we deprecated of November last, and by a new interface that I'm going to talk about now. This is all embedded within a digital collection strategy that the Rijksmuseum hosts, which is incorporated in an overall digital strategy, where the belief is that digital is a shared responsibility, and especially for digital collections, that we have an holistic view on what we want to offer, where the motto, everything's connected, very much applies to what we're trying to do. And also we think applies to what the museum's ambition is to do. We're committed to linked, open, usable data. So I'm very honored to speak before the inventor of the concept. But at the same time, we also believe that there's no one size fits all, neither regarding systems, standards, etc., etc. And I think that might be an interesting point of discussion maybe afterwards. The existing infrastructure that we had for the last 12 years, and which we deprecated at the end of last year, was what I tried to draw here. Basically, library collections, object collections, dam systems, archives, and what we're implementing still this year is a research data repository, are too tightly, basically, coupled architecture and too tightly linked to each other, which made the whole architecture and the whole infrastructure really slow, vulnerable, and basically too complex and too unsustainable. And by 2020, I think we agreed to look for another solution, where the whole challenge also was that a lot of the collection silos were the responsibilities of the museum, but the website and the data lake feeding into the website was the responsibility of a commercial partner, which basically resulted in technological and organizational lock-in that we wanted to end. What we came up with is, I think, the most dense slide I've ever made. My condolences. But basically, these are the core components of the new infrastructure that the collection IT team came up with, where what we build is an infrastructure that connects systems and makes data accessible through data services, and architecture that's based on microservices in the cloud. It's fundamentally a linked data architecture where we connect diverse data in a knowledge graph, use ontologies and vocabularies to standardize data and capture the richness of the different domains, and basically try to ensure long-term usability and accessibility of the architecture that we've built. It needs no saying that it is way more complex than the architecture that we had. And that's also one of the challenges that we're are confronting the next years. But it's, I think, it leads too far to explain all this. But I think the main thing is that in between the collection silos, you've now have a semantic integration layer and data services, making it a more robust infrastructure that's more flexible. For the real nerds, if they're in the audience, I would advise to go to the web and where you can also find access to the data and to the different APIs where to connect to the data directly. The whole project that we've set up was basically led by a core team of the collection IT department, which is in the Department of Research Services that I'm responsible for. But basically the team is responsible for maintenance and support, and also the research and the R&D project lead and participation in the project, where we hired additional team members and developers to set up parts of the new infrastructure and build it. It was funded by the Rijksmuseum COVID Relief Fund, but also private and commercial funding. What we think that we've succeeded is in taking back control of the collection data infrastructure from a commercial firm with enhanced data accessibility and knowledge dissemination, where we have improved internal collaboration and a possible integration with other institutions and external collections, that we managed to future-proof a digital strategy, and we hope it to be relevant for a long time. This is the new collection online website, where what you've seen here on the screen, completely on the right, is the diversity of a semantic search approach, where you can holistically collections. And at the moment, what's only connected yet is, and I'll go back, is the library and the object and the DAM system. And the archive and research data will be connected to the website, the integration layer, and in the end, the website in the 2 coming years. Basically, this is a kind of quick description of the search interface that we've built with entity-based search, where you have contextual connections where users can search through all kinds of different entry points, where there's data enrichment using structured metadata to and multilingual support. There's linked open data that enables integration with external data sets, and a visual exploration where users can navigate a collection using interactive maps, timelines, and also some standalone AI tools. What I've briefly presented in this lecture are the evolution of cross-collection searching, the innovation in Rijksmuseum's data infrastructure, and I think what we hope to stimulate is potential collaboration and the mission of the department to support fair and open research with the aim to connect people, art, and history through information and data. Here you are.
Yeah, am I back? Yes. Thank you so much for this tour de force, I think, in 20 minutes. Certainly the overview, the overview of the history of the whole procedures rings a bell, and certainly resonates with some of the work that we've done at CERL. More about that later, but are there questions for Saskia? I cannot see the online questions, but I'm sure somebody in the room can. In the room, Christina Donley has a question for you, Saskia.
Hi, Saskia. Thank you very much.
Hi, Christina.
Hi. In the process of integrating all this data, did you rely on the cataloging that was already done, or did you have to produce or enhance cataloging of individual, whether of the three departments, let's say?
Oh, we very heavily use the existing cataloging, but it's also fair to say that we needed a lot of standardization and to build on it and to proceed. So data enrichment and standardization are to take into account in order to be able to do what you do. Thinking things.
Thank you.
Further questions? If I may, can I ask a question? You said library data is connected in this system. What shape does that take? Do you see like the catalog record or a digital object, or how does that work?
What we have connected up till now is the metadata of the library. So the 500,000, the collection of 500,000 books and publications is completely cataloged. But we're now starting a process where we will digitize the special collections of the library as the last part of the digitization of the museum collection. So it's only till now.
Beautiful. Any further questions? In that. Yeah, no, Saskia suggested that maybe in the panel tomorrow we could talk about no one size fits all. So I think that's an extremely important topic that I would like to revisit tomorrow. Okay, thank you, Saskia. So I hope you stay online for the next presentation.
Yes, yes, definitely.
Wonderful, good. In that case, I'm very happy to announce and present the next speaker to you. That's Robert Sanderson from Yale University. His colleague Michelle is in the room, but here online is his presentation about LUX, and that is the cross-collection discovery system that is prepared at Yale. Robert, thank you for being here, and the floor is yours.
Thank you very much. Do you hear me okay in the room? Yes.
Yeah, we can hear you.
Perfect. Just share my screen.
And we can see your screen.
Perfect. Great. So yes, indeed, thank you very much for the invitation to speak, and I apologize. I regret sincerely not being able to be there in person. So I'm Rob Sanderson, Senior Director for Digital Cultural Heritage here at Yale. I work across our libraries, archives, and museums to help the collecting organizations connected and consistent in the way that we do things. So, first of all, what is LUX? We think of LUX as a groundbreaking discovery and that provides unified digital access to the collections of our museums, libraries, and archives. So it's a substantial collection with more than 17 million objects, comprising more than 13 million works. And beyond that, we've linked the concepts, events, places, people, and groups that then provide infrastructure to the way that our resources are connected. The two highlighted words, though, in the description, I'd like to focus on first collections, and what we mean by that, what are the collections that have been connected, and what do I mean by unified following that. So first of all, we have both cultural heritage and natural history collections here at Yale, with 3 museums and a substantial library and archival collections. The museums being the Yale Peabody Museum, the Yale University Art Gallery, and the Yale Centre for British Art. And here depicted is the beautiful book tower in the Beinecke, for which Michelle is the lead. So to walk through some of those collections and how we thought about connecting them, we realized that even though different topics and subjects and objects in each of these collections, that they were in fact all connected. So for example, here is a fish fossil in the Peabody Museum, discovered by Benjamin Silliman, an early professor of chemistry at Yale. And he wrote this letter to after who then funded the museum, which is in the archives and the special collections in the Beinecke. Silliman was married to this woman, Harriet Trumbull. The sketches in the art gallery. Harriet Trumbull is the niece of John Trumbull, the revolutionary artist, who, along with his mentor Benjamin West, painted this painting, which is in the Yale Centre for British Art. Also in LUX, we have more recently included the School of Music's collection of musical instruments, which is around 1,000 musical instruments. The Campus Art Collection, which is currently being catalogued and described. The Institute for the Preservation of photographic paper and reference materials, and the Paul Mellon Centre in London. So then what do I mean by unified? First of all, it was Z3950 or Z3950 at SRU, which I worked on. However, those federated search systems could not, on the fly, produce a reconciled set of descriptions. So if you had the same person or the same work or the same object in each of those databases, you would get one record for each database rather than one record for each work or for each person and so on. So here, for example, is the record for Benjamin West, and you can see that there are contributing records from Yale, but also contributing records there on the right from a variety of sources, including the German National Library, French National Library of Spain, the Library of Congress, VIAF, Getty's ULAN, and Wikidata. Then, given that we've reconciled all of those external sources and internal sources, the record should have as much knowledge presented as we can collect from those sources, by which I mean it should be enriched rather than just presenting the knowledge of Yale. This then contributes to this middle part where we do not maintain the Hebrew or the Arabic forms of Benjamin West's name. We get those from the external sources. And finally, the record should link to the records of all of the other entities that are related to the entity described by the record, or it should be connected. And here we see these connections back into the collections, such as the objects that were created, encountered, or influenced by Benjamin West. And then in these other tabs, there would be works created by him and works about him. So then we can redescribe Lux slightly to say that it is a groundbreaking knowledge graph, providing unified digital access to our collections. What do I mean by knowledge graph? Well, this is the hardest part of any description of knowledge graph for the creation of one, which is the empty white. So we'll start with that painting. It's an object that's got of course we're all familiar with from subject headings and name authority files, such as that La Hogue is part of Normandy, West was a member of the Royal Academy, and painting has a broader concept of visual works. So this is not yet a knowledge graph. However, we will very quickly get there because we can also add non-hierarchical relationships, such as the auction catalogue, which is about the painting. Or the fact we also have Trumbull's archive, which is about painting. It's about West and Trumbull. It was created by Trumbull. And now we have many connections just centered on this one object. Now multiply that by the 15 million objects that we have, and you get a sense of how we can connect across multiple collections within the university. Why would we even attempt to do such a thing? Well, because users don't and should not need to know all of the different systems that they would have to go to, and we counted about 25 of them in order to discover the information that they're interested in. So, for example, the YCBA has a collection site, the archives, the Peabody Museum, the Art Gallery, Quick Search, and so on, which of course left our users with this horrified expression of the various interfaces that they needed to learn in order to discover anything that they could about the objects and works they were interested in. Why did the university think this was a good idea? Well, Lux directly advances the mission of the university, which is excellence in teaching and learning. So we have a lot of work put into making sure that our collections are part of the teaching and learning activities and mission of the university. We have students working with the collections constantly, including not just art history and humanities, but also in medicine and science and beyond. Excellence in research. It's of course impossible to do research without a world-class library. And to prepare our students to be leaders by giving them a sense of the world and the history of our world. Also, of course, Lux directly advances the goals of our division, in which are to preserve and make accessible the collections. So, of course, it would be easier to preserve the collections if they weren't accessible. However, it's no good not having them accessible for use. And digitally, and as functional as possible online, makes them the most accessible that we can. improve our decision making. How did we do this? Well, first and foremost, of course, our collaboration. There was 5 years, or has been so far 5 years, of very sustained collaboration across the division with all of the libraries, museums, and archives participating. This led to a trust that previously hadn't been as extensive as it has been, and some cultural transformation as part of working together, which has then led to generosity, accountability, and excellence. We also have collaborated with an external company, Progress Logic, which provides the back-end database in which we manage the knowledge graph. Also, of course, it was a lot of hard work over several years, and overall, certainly close to 30. There were some political requirements as well when we decided what and how to go about this. In particular, there should be no new system of record. So the question from Christina is an excellent one to Saskia about, does the knowledge graph require new cataloging? Well, with millions of MARC records, millions of records in EMU, TMS, and archive space, we could not afford to create any new systems of record or do any significant new cataloging to make this work. So then that means that it should be rebuildable from code only. Meaning that if we were to lose Lux, and it's a service that runs in AWS's cloud, if that system were to completely be destroyed, we could rebuild in under a week, and most of that time would be downloading the records from the external systems. If we were able to maintain the backups of the external data, it would be up again within a day. There should be no editing interface or custom persistence needed. Again, that would require a system of record to maintain those changes. And it doesn't replace existing systems. It just provides a discovery interface whereby you can either stay within Lux or you can reach out to those existing systems if there are features that are not available in Lux but are available in those underlying systems, such as, for example, Lux does not provide a way to request a book from the library. That's just a library concern. We want to get the user to the book so that then they can make that request using the dedicated systems within the library. And secondly, everyone is welcome. It must enable cross-domain discovery, so not just cross-collections of the same type. It's not just one art museum and another art. For the participating units, which we have seen through the collaboration and the changes to our culture through that collaboration. And finally, the work process as well as the technical product must scale, by which I mean that the amount of effort that is put into Lux by the units should not take away from their ongoing work to catalogue their collections or any other piece of work that they're working on. The technical product, of course, has to scale as well. We have 42 million records, about 2.8 billion triples, if you like numbers. So we test with 150 concurrent users, and that doesn't even slow down the system. So we know that we have a lot of capacity left within the current product. I must note, though, we do have a few rows in custom spreadsheets. Those are to deal with when the information that we present needs to be changed, but it's not from a system that we have access to. For example, when there are errors in the German National Library or the Library of Congress, we can't just go and change those records to fix them, so we need to have an overlay system that can make very targeted changes. to those records. So, in talking about records, then, we have found that they are a very necessary construct still, even though we use a knowledge graph. So, in terms of the graph, writ large, it's not really comprehensible to anyone, particularly in its complete form of 2.5 billion relationships. Equally, constructing records from a graph at runtime, when someone is querying, is really hard and very expensive computationally. So it turned out that we needed to maintain this notion of records within the graph for all of our core requirements. So it should be unified. We need something to link to and from, an anchor for people to understand what is being described. It should be usable. Graphs are not easy to understand by end users, but also by our back-end software engineers. There needs to be some sort of unit of search, something that you are looking for that can be performant as well as understandable. It should be performant. Faceting is an important aspect of user interfaces, and they're very expensive to process if you don't have a notion of a record. It should be implementable, which is, graphs are very hard to work with as data compared to records. And it should be open, allowing others to use our data in their system. And again, records are much easier for others to use than a graph. So for technical folks, and to align a little bit with what Saskia was talking about, here is our architecture. So across the top here, we have the individual systems within Yale in blue and the 20 plus external data sets that we use over here in grey. We use a harvesting approach rather than federated search. So we fetch the changes nightly from each of these systems and then transform them into one internal format, for which we use link discussion to have about whether there is necessarily multiple formats at once, or whether there is the possibility of a cross-domain standard of use. We then reconcile the records, or the entity that we know that when the archives and the art gallery and the Library of Congress are talking about one person, that really is the same person. We then change all of the identifiers or add an extra identifier so that we can have an internal identifier for that one entity. We then merge all of the records that are describing that single entity to end up with a consistent, coherent data set. We load it into MarkLogic, and then with some web caches for performance, we make that available via the interface. We have a notion also of continuous improvement, both for the graph and for the system. So we're always adding more collections, both from internal and external sources. We have ongoing improvements to the modeling. One of the things we're working on at the moment is stratigraphic layers to enable the layer in which a dinosaur or fossil was found to be modeled, and increased alignment with standards. For the system, we're working on AI-powered natural language queries, transitive queries for hierarchies, such as find me a fossil that was discovered anywhere within a particular broader location, geospatial queries, personal saved collections, and additional visualizations. So I'd like to take 5 minutes now to give you a demo of what Lux looks like. Just stop sharing for 1 minute while I switch to web browser. So we'll search for Trimble. And yeah, as you can see, we then can do the sort of simple keyword search of Google style and very quickly get results spread across the different types of entity that we have in the system. So there are objects, physical or digital things, works, which is either the textual or visual, intellectual work of carried by an object. Collections, which are either collections, the set of objects exhibited in an exhibition, and so forth. People and groups, and so here's Trumbull. Places, Trumbull in Fairfield County or Trumbull County. Concepts, Victoria, Trumbull, the fictitious character, or property in, or maps of real property in Trumbull County, Ohio, or the history of Trumbull, Connecticut. And events, such as the Saratoga campaign or the Battle of Bunker Hill, which Trumbull painted, also the exhibitions that mention Trumbull or his works. So we go back to objects. So it's still, unlike the Rijksmuseum's amazing, extremely beautiful interface, we have opted for a more sort of traditional repository style interface. But one of the important aspects that we talked about before was faceting. So you can say you must have a digital image that should be categorized as being a portrait. You can facet by date, so 1780 to 10, to get down to a smaller number of objects. We'll pick this one, somewhat at random. So this is a miniature of Eunice Trumbull. It is digitized not as deeply as the Night Watch at the Rijksmuseum, but still far more deeply than you could ever see if you were to lean into the object in person. It's only about 1.5 inches tall. Then scrolling down, you can see that there is your typical tombstone record of classifications and materials and when it was created and the credit line and so forth. If you were in a regular interface and you clicked on the artist, you might expect to search for objects also created by that person. But because we have a knowledge graph where all of the entities have their own records, we can then go to the record for Trumbull. And then here on the left, as we saw earlier, there is the links back to the objects that the person created, works that they created, works about them, either visually or textually. Over here on the right-hand side is the information that we've merged from multiple sources about the person. There's also the possibility for visualizations that can be manipulated, such as this timeline, to then say look at the works in a particular year. So in 1790 we have 18 objects from Trumbull and 2 works published at that time. However, the one that I want to show you is the main or core benefits of a graph is you can produce queries that go through the graph to find correlated entities. So, for example, George Washington, President George Washington, is the subject of collections that are also about Trumbull. He created collections about Trumbull. He's the subject of collection created by Trumbull. He co-created works with Trumbull and is the subject of works about him. Here is Benjamin West. So West co-created objects with this person, and here is that painting from ICBA. If we start back up here, we have a lot of information about Trumbull, again from mostly from external sources. But let me just go through to here. So we also had then, of course, places such as New York City, again linking back into the collections of what objects were made or encountered at New York City. And then each of the concepts has their own page as well. So again, linking back into the collection, but information about sugar tongs. It turns out that the Yale University Art Gallery loves sugar tongs, and that we have 737 of them in the collections. Just to end with one more thing, show you advanced search. I won't create it by hand, but my favorite search is this one. So by having a graph, we can also give access to researchers and the general public to the knowledge encoded in that graph. So this is a search for paintings that depict people who found fossils. So it's searching for objects categorized as a concept, and that concept has a name of painting, that show a work, which is about a person. Which person? Well, people who encountered objects that are categorized as a concept called fossils. And here are the 10 paintings that we have, such as Benjamin Silliman, James Dwight Dana, the famous paleontologist O.C. Marsh, and so on. So these are paintings in the art gallery that are of people who found fossils, and of course the fossils are in the Yale Peabody Museum. So here's the object. It shows a work which depicts a person, O.C. Marsh, and then here are those fossils. So I will leave it there, and I would be love to hear any thoughts or any questions that you might have.
Whoa! Thank you very much. We have a little of time for some questions. Does anybody have a question for Robert? You did.
Just a small question. What is the biggest challenge when you are working with museums and libraries?
Oh, yes, just a small question. So to me, the biggest challenge is the focus of what museums and libraries want to describe about their collections. So typically, museums have many unique individual objects. You know, there is a painting or a sculpture or a photograph, and it's the physicality of the thing which the museum curator is most interested in. And you know, they think about it from this is a unique physical thing perspective. Whereas libraries are the opposite. You know, there are many copies of Philosophy 101 in the library, and the library then cares about the work, the intellectual work, rather than about the physical thing. And of course we need to track the physical objects. One need only look at the British Museum for what happens if you do not. However, the focus of the cataloguing is the work rather than the physical object. Archives are interesting because due to the scale, archival practice has typically been not item level cataloguing, but collection level descriptions, which again is different, right? It's not even just the work or the object, it is objects and their works en masse. So the most challenging thing we've found is both how to connect these things together at the data level when they are being described from very different perspectives, but you know, that's a relatively easy matter with linked data. The really hard part is how do you have a user interface that makes it clear to the user what those differences are. So the biggest challenge and the most frequent question or complaint that we have about Lux is that there is these 3 different tabs in that interface. You know, the objects, the works, and the collections, which by and large map to museums, libraries, and archives, but not exclusively. So if you search for something and you don't understand, you know, physical object, intellectual work, collection of things, then you don't know which one you need to be looking at. And of course, most users don't know that. It would be much nicer to have a single list that was better ranked and integrated. However, the complexities of doing that when you have many objects that have the same work, and some of those objects have multiple works, and some of those works are in multiple collections, you know, the connections start to get lost if there is only a single interface for all of the search results. So we are still looking for a better way. However, yeah, at the moment, the 3 tabs is where we'll come to.
May I perhaps ask a related question? So our library data doesn't, your graph depends a lot on relationships between concepts or entities in the various catalogues. Now our catalogues don't have that relationship, so how did you arrive at that connection between an item in a museum collection and an entity in a library collection, for example? Yeah,
so we have a code base that does the reconciliation and linking. So most of it is completely deterministic. It's not AI, it's not machine learning, it's not probabilistic. We rely on the fact that there is a network of identities that the libraries, such as all of yours, have contributed to say that, you know, in the Library of Congress, the record for a person in the Library of Congress Name Authority file is the same person as described in a different record at the Bibliothèque Nationale de France, or in the German National Library, in the Swedish National Library, and so on and so forth. So by connecting from one system to another, we also include the systems that are used by the art museums, by archives, by the Natural History Museum, and so on. So long as we can get from the original record within the library, archive, or museum to anywhere, to any system externally, we can then almost always get to the other systems that are in use in the data. So, you know, for Trumbull, we have a connection to him in ULAN, the Union List of Artist Names from the Getty, and in the Library of Congress Name Authority file and Wikidata. Those are the 3 sources that the 3 different domains typically use, whereby we can then connect him together across those different systems from the objects, archives, and works that he's associated with.
Wonderful. A quick one. Christina Dondi has a question for you.
Thank you, Rob. So it seems that the books are described mostly as works, but in the case where books, you know, you want to describe them as an object, because of course they have a history, and we are very much interested in that. Is it right to assume that you describe them as you describe the objects in the museum, or you have special categories?
No. They are the physicality of the book, you know, particularly from the binary, is described the same way as we would describe a manuscript in the museum, you know, or a painting in the museum. It's a physical carrier of a work, and that work could be an image, or it could be linguistic content. No, it's there's not a special category for the holdings of the library. They're just physical or digital carriers of works.
Thank you.
And Saskia, I see that your hand is raised too.
Saskia?
Yeah, hi. Thank you, Rob. That was wonderful, as always. Lux makes me happy. I think that every time. What you were describing about users and the challenge to explain to users how to use a semantic system or semantic search is a challenge that we experience as well. And I was wondering whether have coordinated with research services or research support how to develop specific research guides, something to help ease the use, because that's something that we would be very interested in as well.
Yeah. So we have tried to do that, and in particular, it's in the sort of the help text, both in and on the right-hand side as you're building queries. However, getting people to read text is a challenge. If I can very briefly share my screen, let me show you where I think we will be going. So this is a development site, and if you can read it, it is lux-data-dev. It is open, but only if you know that particular URL. So we're looking at using AI, as you were talking about, to help build the query rather than make the user understand. Right? So the user can express it in their own natural language. I want books about agile in the sense of software engineering. And you get books about agile in the sense of software engineering, some 39 of them. But if we just click here, the AI constructed the search. Right? So it's looking for objects categorized as books that include works that are about the concept of the concept, which is identified by Wikidata as Q30232. The user doesn't need to ever see that. But that is the concept of agile software development. So, yeah, hope that through the use of natural language queries mediated by AI, the user won't have to understand those details, and they'll be taken more directly to the records that best fit their particular information need.
Cool, thank you.
Cool. Yeah, cool is the word. What I like very much about your system is that you're showing the graph, or allowing users to understand how the graph put together, so that it's very transparent. And in the corner of my eye I saw something, what can I do with this image? And I thought that was extremely helpful as well. I need to close this. We could spend another half an hour on talking to you about your amazing system. Can we thank Robert once more with a little applause? In the interest of trying to keep to the timetable, I'm quite happy to introduce to you the next two speakers, Constanza Blaskovic and Santiago del Bosque Arias. They are from the Factum Foundation, and they're going to introduce to us the Celine project for 3D digitization and cultural heritage. Very much welcome to you both, and give us a beautiful paper.
Good afternoon. Can you hear us?
Yes, we can hear you.
Great. Thank you very much for inviting us. I'm going to share my screen.
Yeah.
Hope you can see it.
We can see it.
Great, perfect. So welcome again, and today we're going to present the Selene project for 3D digitization of cultural heritage. Me and my colleague Santiago del Bosque Arias are working for Factum Foundation for digital technology in preservation, and well, we concentrate pretty much on the Selene project, and so we're very happy to introduce it to you. But first, I just wanted to quickly introduce what is Factum Foundation. It's a not-for-profit entity founded in 2009 in Madrid. Among the other activities, we concentrate especially in recording of cultural heritage, rematerialization, and dissemination. Recording with as high-resolution and non-contact recording. We specialize in 2D, 3D, and 2.5D, a concept that probably we will introduce later. And to do so, we usually develop our own technologies for recording. for example, for books, so for 2D photographic sets, or for photo libraries and other archival documents, but also 3D, fully 360 degrees, in this case the Veronica for, well, humans. And at the same time, we use also commercial recording technologies as LiDAR and photogrammetry, in this case for architectures or sculpture, bigger sculptures. And going back to the in-house made recording techniques, this is Lucida for paintings and very subtle reliefs. It's a scanner. And the latest Selene, well, I will explain later another photographic technique. Then another keyword for our activities is rematerialization, and we master in the creation of exact replicas and reconstructions for preservation, exhibition displays, enhancing accessibility, or sometimes making it possible, and research, of course. For example, we rematerialized, we made replicas of volumes, books, including illuminations and their bindings, but also sculptures. As you can see, this is a point cloud model, and this brings back again to recording. For any kind of rematerialization, the first step in our work is the digital recording of the heritage, and then the 3D model gets more and more detail in any part of the object, in this case, funerary sculpture of Cardinal Tavera in Toledo. And then the last part, after the printing, the craftsmanship, the craftsman skills are coming into play. And so each rematerialization is a mix of digital skills and very human and very artisanal skills. This was for sculptures, in the same philosophy, different methods, of course, for paintings. Even very large painting and very, very large paintings, as this one that is for you. One of the first big projects for Fashion Foundation. This is the replica of Nozze di Cana by Paolo Veronese. The original is at Louvre, and this is the rematerialization for the refectory of San Giorgio Maggiore, now Fondazione Giorgio Cecchini. Third step, dissemination for digital accessibility and physical accessibility, cultural heritage. The digital part, well, is exactly what we are discussing today, and it can be viewers, it can be in catalogs, it can be multi-layered viewers of single pieces of art. Or again, physical model that cannot be, the original cannot otherwise be displayed. Dissemination for us is also sharing the skills and the methods through educational projects, as in workshops that we organize. As you can see, this is in the Grotte Kerk in Naarden, and or online.
Hi, everybody. We're really glad to be here. So, this is the Selene photometric stereo system, which is a non-contact, ultra-high resolution scanning system designed to record both color and surface relief, or flat or semi-flat objects like painting, manuscript, book covers, good blocks, or even textile. The core idea is, with the Selene photometric stereo system, we take 4 photos of the same area, but each one lit from different directions using 4 xenon flashes placed around the camera. This technique is called photometric stereo. Technically, the system is built around a Canon R5 with a 50mm lens mounted on a motorized structure that moves across the surface of the object. Each section is recorded really fast. I mean, less than 20 seconds per tile. Then these tiles are stitched together into a single image. So using those 4 images, we can extract different layers of information. On your left-hand side, you can see the albedo, which is basically a color image without any shadow. So it's pure color and reflectance. On your right-hand side, watching the screen, we can see the shaded render of the depth map. With the depth map, we can understand how deep or wide each part of the surface is, down to around 15 microns. With that data, we can generate the shaded render, like this one that we are looking at. And the shaded render that really brings out even things invisible to the eye. With the naked eye, we cannot notice those details. Selene works really well with matte and shallow relief surfaces, but it can also handle shiny and translucent ones by using some extra tools like cross-polarizing filters. So using all these tools, we can reduce the reflection and getting clean and accurate results, even with more difficult materials. So here is a video. Can you see that? Yeah, I hope.
Yes.
Yes? Okay, perfect. Thank you. What is exciting about that Selene doesn't just create images. It, as Costanza was saying, it generates real, measurable 3D data that can be used for analysis, virtual exploration. It can be used to research, or even making facsimiles that reproduce both the color and the surface of the original object. That is really important for us. What we see on this slide here is the facsimile of the Pacheco's painting Gratis. Now, to give you a really nice example of how this works in practice, I would like to mention our recent collaboration with the Instituto Valencia Don Juan here in Madrid. This is a private cultural institution dedicated to the research and conservation of Spanish heritage, with an incredible, diverse collection, from metal, textiles, ceramics, and paintings to coins, seals, or books. Actually, too many manuscripts. Working with a collection, this broad really highlights the versatility of the Selene system. In just a few months, we were able to scan and process over 150 objects, each one and very different in terms of material, size, and surface complexity. But beyond the technical achievement, this collaboration shows the real value of high-resolution recording. The data we have captured, we allow researchers and the public to access and explore these artifacts remotely with a level of detail that would be impossible through traditional methods.
I'm going to make a step back to the first collaboration with the Selene photometric stereo system, and probably the collaboration that started the Selene project itself. It's a collaboration between both the libraries, Oxford University and Factum Foundation, with the funding support of the Lenny Henley Trust. The project is Archaeox, Analysis and Recording of Cultural Heritage in Oxford. In 2022, Factum Foundation installed the very first functioning prototype of the Selene. And well, it has been installed in the imaging department at both the libraries. One of the first material that have been on which it has been tested, and one of the first collection is the rolling copperplate collection. And in this example is very clear how the rusty and almost rusty, but anyway, it's difficult to read picture on the left, which is the albedo, the color image. Is not able to to show exactly the design, the etching on the surface on the plate, which is very visible on the example on the right. It's the same copper plate, but on the right we deprived the surface from the color, and it's a recording done with the Selene photometric stereo system. I think. Here is a visual example of the difference in a close-up, and it's possible. Well, this is the heated map, and it's possible to see through GIS technology viewers. It's possible to investigate the depth of the relief, the surface relief of the copper plates for confronted with others and confronted the same relief on the same object. This is the reverse of the same copper plate, and well, it was almost invisible, but it was we had hints that something was etched on it on the surface, while when recording it with Selene. This got more clear, more and more. We have been actually, John Barrett, the technical lead and senior photographer at the Bowden Library, managed also to extract the real pentagram indentation on it. Always on copper plates, one of the latest research, one of the latest recordings revealed on the back of another copper plate, one, more than one, the first etching copper plates by William Lake. But Selene has been tested also on parchment, in this case, always in a collection in Bowden Library. It's an Act of the Apostles Latin text. In some part of the pages, it was almost invisible, but there was a subtle, there were subtle dry points inscriptions. And thanks to the recording with the Selene photometric stereo system, it has been possible to read and study the content of these inscriptions. And Jessica Hodgkinson made research on this and found out the real story of Edinburgh, probably one of the owners of this manuscript of 8th century. And it's very interesting to know that the most prominent of these lines, of these inscriptions, are only 15-20 microns in depth. So almost able to be read and understood by the naked eye or with traditional photography. The system has been tested also on woodblock prints, in this case in the Japanese collection of libraries, and the texture of it is now very visible thanks to these recordings. Another project, another test or another study. One of the most exciting was in the Gulf map, and this is the map. This is the depth map of the map. I'm not sure while sharing the screen and we are online if you manage to see the quality of the surface derived from the color, but the recordings with Selene made it possible to understand better the methods, the production methods of this incredible map. And thanks to the data collected with the Selene recording system, we managed to make an exact replica of the same. In this case, you can see exhibited, so displayed for the public. Another case of replica and accessibility and research as Selene as an accessibility, also physical accessibility research tool is this one. This is one of the Ashama seals. They are 2,500 years old, and they are made of unmarred clay. So they are extremely delicate, but extremely important as cultural heritage. And well, on the bottom is the real size. All of these are not real objects, but are copies, physical copies of these seals recorded with Selene. On the upper part, they are enlarged 10 times, I think, or even more. And well, this even brought to the recreation of and the design of what was the original tool that had been used to realize the seals themselves. So a rematerialization not only of the object, but a research rematerialization of an object that doesn't, the tool that created the object and that doesn't exist anymore. Selene photometric series system within the project of Archeops has been tested also on the drawing of Raphael at National Museum. Here you can see the result of the composite render, so color and 3D all together. Also on scientific cultural heritage, in this case of the Oxford University Museum of Natural History. And so fossil 3D, the composite render, a specimen of butterfly, the color, the composite, color plus 3D, and the subtraction of the only 3D of the specimen. The Archeops project had as a goal to demonstrate how 3D and digital technologies are crucial for research and to reveal details that otherwise are very difficult to study or even to see. But a very important part of the project was also how to make this data accessible. And so part of it's a video, I hope you can see. Part of the project was also the development of tools to integrate the 2.5D and 3D data of the Selene in the existing database of Boolean libraries, so digital Boolean, and how to integrate plugins to visualize this data in the AAAF viewer, in this case Mirador. And as you can see, there are parts, there are details, plugins that are new, and the next will be like, there are several tools to enhance the visibility. Of course, only for visualization purposes, so to enhance the visibility and explore as if we had the torch in our hand and we were exploring this object. Selene have been tested also on other materials, and well, I go ahead a bit. So it's possible to explore the object, in this case, number CERL, changing lights to improve visibility and maybe explore it in every corner as if we had it in our hands, more or less, but of course without touching it and without putting it at risk. After the first period of the Archeops, which is an ongoing project, an ongoing research project, after the brilliant results had, Factum Foundation and Archeops decided to go ahead and enlarge the circle of people, members of the Selene circle, which is growing as a community using the Selene photometric stereo system in their imaging labs. In 2023, Princeton University Library acquired one Selene unit, and this is the lab during the training. And one of the first tests was very intricate cuneiform tablet. The first results were very encouraging. Other recordings and studies were made on very different material, but in this case I chose this manuscript and this kind of seal. The seal is under study, and thanks to the Selene recording, it will be easier to have the data accessible for the scholars. Sorry. In 2024, the British Museum acquired a Selene unit to concentrate at first on cuneiform tablets. Here you can see Jorge Cano and Matilde Toulon-Ricci. Jorge Cano is the developer and head of research and development at Factum Foundation, which together with the team at Factum developed the Selene system. And here we are the curator, one of the curators of the cuneiform tablet department at British Museum. This is part of the collection. Of course, it's very fragile, huge, and these are some of the results that are really encouraging. Recently, in February, the John Rylands Library of Manchester University acquired another unit here during installation, and this is one recorded in Borja map. Here you can see how the Selene recording system head is moving. This is, of course, speeded up to let you see the process. The head with the camera and the lights are moving and taking pictures at the same time of sections of large objects then stitched together, what was Santiago telling you before. At John Rylands, they tested it also on, as you can see, on book bindings, revealing, in some cases, very subtle details of them, or enhancing the visibility of, as in this case, print. Or in this other case, is the papyrus, is the back of a papyrus, and well, another seal that was very difficult to read now is much more easy to get studied. And this piece will go soon to an exhibition, and also the research made possible with the Selene, well, have been crucial for this development. This is again an example of the Museo Lázaro Galdiano here in Madrid that Santiago explained before. Another very interesting, let me check the time, maybe I should speed it up a bit. This is another very interesting example with wood blocks at the Plantini Moratus Museum in Antwerp. As you can see, this is the color, this is the composite, the visibility is really enhanced. This is the depth map, so no color, just details. Another example in the Museum of Lakenal in Leiden, this is a book, well, in very difficult conditions, complicated conditions. It's a sample book, of pieces of wool. This black are wool. And of course, the museum had this problem how to record it, and even when recorded, how to read what is written, because of course it is very difficult. So the first step was to open the book, record it in 2.5D and 3D, both with Selene, photometric stereo system, and photogrammetry. This is a result with Selene. This is a photogrammetry render of the 3D shape of the sample. Same from a different angle. It's a render. Same, it's a render. The distorted page shows a combination of the 3D shape taken with the photogrammetry and the 2.5D information, which makes more visible the text. This is an attempt, one of the first attempts of flattening the page, digitally, of course. And here you can see from the original render, the processing of flattening the page and the processing of making the text more readable. Same. Another very, very exciting project was the recording of this globe, the sheep's globe. It's paper. Have been recorded. Sorry, should we stop? That signal was. We don't hear you. Sure. Very good. So I will stop.
Last example and round it off. That would be brilliant.
Okay. Yeah, this was the last example. And both photogrammetry and Selene, well, the images talk by themselves. I will stop now. Thank you very much.
Thank you. Thank you very much.
Thank you so very much for the beautiful examples that you've shown us, and also the absolute brilliance of the results that you get out of this project. Can I ask if anybody in the audience has a question? So my question is, are you working on a sort of, these were all examples, and I couldn't quite get a sense whether you are also working on a research project that has a larger body of work and then a research project attached to it, or something like that?
Yeah. Well,
No, if you want, you can start.
Most of the examples from the Berlin Library. Each example is connected with a research project, and for the other institutions, museums, and it's usually a request by the institution that has some difficulties in make the heritage accessible, or the request is for example, to improve the research or continue the research, and look for tools for improving the research.
Improving the questions and improving the answer to those questions. Like in some cases, we work with conservators that they need to explore the surface of some kind of objects, and it's really important to understand that the surface of an object is really important without the color. And when you're working with the surface of something that usually, not always, but usually most part of the people think it's flat, but it's not flat, it's actually 3D. And it's really important to know how do we have the chance to analyze that part.
Yes. I can absolutely see the advantage of that. I have tons of manuscripts with crossed out provenance marks. I want to give them to you all so that you can read what the name is underneath all the crossed out bits. Can I thank you both again for doing this presentation and showing us these wonderful possibilities. So I'm going to go on to the next paper and reduce it a little bit, I'll try. My name is Marion Leffers, as I said, and I'm going to have a quick chat with you about cross-collection search at CERL. As Saskia said, in the 1980s and 1990s, and actually a bit earlier in the 1960s, we saw an increasing development of electronic catalogues, which eventually also included catalogue records for early printed books. Libraries had their card catalogues keyed in. Oh, I also have a PowerPoint presentation somewhere. There we go. Can I move it on? A colleague is helping me. And it's not pretty pictures, but it's all the acronyms that I'm going to use. So we start with that one, and we have put it here. Yeah. So, libraries had their card catalogues keyed in, and cataloguing in computer systems became commonplace. Against this backdrop, librarians at the Bavarian State Library, the British Library, the National Library in Edinburgh, and the Bibliothèque Nationale de France, with several others, observed the examples that were set by the Inknabler short title catalogue and the English short title catalogue, and you see all these acronyms here, and they began to explore the possibility of creating a database for European early printed books up to about 1830. The vision was to bring together the electronic records created in libraries and aggregate them in one place. Old school, therefore. When the database was created, the focus was very much on providing a resource for derived cataloguing, that was, allowing cataloguers to reuse the records from other libraries to speed up the process of cataloguing in their own institution. In 1992, CERL was legally established, and in 1994, work began on the the hand-press book database, as it was then called, and we now call it the heritage of the printed book. From the start, in 1997, when the HBB database first came available for CERL members only, the HBB boasted harmonized data and extensive specialist and tailored indexing. The rich and diverse content of the aggregated records was always retained, but mapped to a shared and consistent structure. Today, 72 files are combined in the HPB, and it now contains more than 9 million records from 26 countries. Since several files in the HPB have themselves aggregated data from a number of libraries, sometimes in the hundreds, in the case of ICU, for example, it's very hard to say how many libraries in total are represented in the HPB, but it may be as many as 2,500 across Europe and North America. Now, can we define this as cross-collection searching? All HPB records are for printed books, with the stray microfilm, map or music score here and there, and the records contain bibliographic and copy-specific information, and many records include links to digital objects, but not the digital objects themselves are in the HPB. All records come from the tradition of bibliographical records in the data format of today, usually Mark 21, and in the past it also used to be Unimark. So that is different from what Yale and the Rijksmuseum had to deal with, and this we saw in the presentations before. The process has similarities though. All of us have to analyze the data, and that is already in the have to analyze the data that we wish to add to the system and determine where it overlaps or can be connected to data that is already in the system. I admit I'm oversimplifying matters a little bit. It must also be stressed that using the same data format, in our case Mark 21, still does not mean that the content transported within the format is homogeneous. There are dialects in application of the formats or different options in use, and they still need analysis and alignment to allow cross-collection searching. In the case of the HPB, data contributions over the years have been a glorious mixture of catalogue and bibliographic records, catalogues contributed by individual libraries and aggregated data sets, data from projects, collections from research libraries, national libraries and religious institutions, conversions of print publications, and today we heard about scraping from websites in Europe and in North America. So different from the cross-collection searching in the Rijksmuseum and Yale, but cross-collections nevertheless. So this is fairly old school, and it has advantages, you know. Since 1999, and remember the database went live in 1997, all contributions from the HPB have been analyzed, harmonized and converted by our for the HPB by our partner, the Data Conversion Group in Göttingen. And during those 25 years that they've been working with us, they used only two main tools for analysis and conversion. First Falcon, and now Maps. And this Maps software, which I will not explain to you, was created last year, and it incorporated the Falcon conversion routines. So there's great continuity there as well. Additionally, over these many years, only a handful of DCG people have done the actual HPB file preparations, about 5 or 6. I can name them all if you want, which has also helped to keep the HPB pretty tidy, even if the data in various Mark and Unimark flavors that we received was a lot more uneven than you might think. The riches in the records that are delivered are retained. No data is discarded, except for maybe some locally defined fields. In this, it differs from, for example, Dublin Core, or the Europeana data model, or WorldCat aggregations. So, our relatively consistent mapping, combined with a focus on the records on early printed books, resulted in a homogeneous dataset, which offers the opportunity for precise indexing and very detailed searching. The lowest common denominator, in our case, is actually pretty high. However, the various cataloging traditions and cataloging languages for names of authors, printers, and place names temporarily put a spanner in the works for users searching the HBB. With the introduction of the CERL thesaurus, which records variants forms in use in Europe, and may offer these as additional search terms in the HBB, the searching can be much improved. There's no such thesaurus for titles, which could also be very useful. In terms of efficiency, perhaps a word or two about the economic side of things. They were definitely setting up costs, monetary, but in the two migrations also in delays in the uploading process, 3 times. First, when the HBB was set up at RLG, then when it had to migrate to the OCLC environment, and last time when it moved from OCLC to VZG, which is also in Göttingen. And there have been last year costs for overhauling the analysis tool, so creating maps, and in our case that was 0.9 FTE for a year. The day-to-day running of the HBB, however, is not prohibitively expensive, an annual hosting fee that is less than 9,000 euros per annum, and we have support of 0.15 FTE, so 15 FTE staff time for an annual program of uploading of 3 new datasets and updates to 3 existing datasets. So all in all, the HBB is by now an old, but also very rich and stable and very reliable database with a trustworthy, transparent dataset. So, should we all go back to old school? There is no shortage of records to load. There are still many libraries that wish to contribute, and the process is very straightforward. The specifications for data download they need to prepare are few and very clearly defined, but at the same time, the reliance on the process of data uploads is one of the drawbacks of the system. When a library corrects a record and enhances it with new information in their own systems, this is not automatically visible in the HBB. So CERL needs to receive a new data dump from the library and upload it before the new information becomes available at CERL. There is no editing facility in the HBB environment, and CERL does not employ an editor. With large numbers of libraries migrating to a new library system, in our case, in our days, many are migrating to ALMA, we're experiencing an urgent problem. The record identifiers in the HBB, which can be used to link to specific records in the HBB, they are constructed to include the record identifier of the search file. And after migration and a new data upload, we find that records have a new record identifier and existing links are broken. We have a system in place that supports keeping the obsolete pre-migration identifiers in the record to make old HBB IDs persistent, if only the identifier of the record in the source system has changed. But that only works if all libraries migrating data make sure that they keep the old identifiers somewhere in the new and migrated records that are sent to us. So please do that. Getting data in is a process for us of uploading data sets. Getting data out is obviously also possible. The system provides for different XML formats. Via, as Saskia already mentioned, SRU, we provide Mark XML, Pika XML, Dublin Core mods. And this allows download of multiple records and also crawling through record sets. Single records can be downloaded also in Mark 21 and other formats via the UNAPI. Support for Unimark export was suspended at the end of 2023. Preparing triples and offering HBB as a linked open dataset is very much on our wish list. Now, the data conversion group is always willing to help by sending a tailored export, but this is not widely known. And the huge impact and value that HBB can have with its rich and amalgamated records for early printed written heritage needs to be better promoted. It opens a door to a wealth of information which needs and allows to be analyzed and questioned in different approaches. The key to opening this door may be the CERL thesaurus, which is available as linked data, lakes open data, and has persistent identifiers which support linking from CERL databases, such as the material evidence in Incunabula and the Provenance Digital Archive databases to the CERL thesaurus. CERL thesaurus records are enriched extensively with links to the GND, the Gemeinsame Normdatei, to VIAF, to portraits from Wikimedia, to Deutsche Nationalbibliothek, to bibliographical records, for example, in the short title catalog, and biographic information from Wikipedia, or, for example, Germania Sacra online. It further supports internal linking from names of printers to the places where they were active and vice versa. The CERL thesaurus was the first database in the AMPL environment, which was later adapted to host the material evidence in Incunabula or MEI database. AMPL was subsequently expanded to include the hosting of several other datasets based on the MEI model. In the AMPL environment, CERL presents the ISDC, the Incunabula Short Title Catalog, since December 2016, and the STCN, the Short Title Catalog, sorry, the first one, Incunabula Short Title Catalog, this one, Short Title Catalog Netherlands, since 2023. Efforts to include the ESDC are well advanced. Data in AMPL is now a combination of databases developed and maintained by CERL, databases curated by other libraries and other library organizations, and databases populated and expanded during the lifetime of research projects. Users of data at CERL may be forgiven for losing track of what they might find here. We are therefore planning to develop an overarching index for the AMPL databases, for which we will adopt a Google-like approach. A user may enter a search term, and the results screen will present a list of links to all records in AMPL databases where the search term occurs. As the HBB is not in the AMPL environment, it will not be searchable through this kind of index. So this approach will unfortunately not create a method for executing a search across the HBB and ESTC. CERL will not run out of things to do in a hurry. An important aim for CERL is to create connections between the data elements and data sets in its system. So I think we're back to the theme of cross-collection searching here, where we want to make connections. The HBB already links to the CERL thesaurus. The CERL thesaurus contains names of former owners created in the context of the Provenance Digital Archive. MEI makes use of the PDA, the Provenance Digital Archive, and it links to the CERL thesaurus and receives bibliographical information from the ISTC. The MEI Holdings database is also used in the ISTC, and so on. But more connections can and should be made. We would like to provide more structure to the HBB, for example, by grouping catalogue records with relevant records from retrospective bibliographies. For this to happen, we need to add more records from retrospective national bibliographies in the HBB, but additionally, catalogue records need to include identifiers for the VD, or for the STCN, or the STCV numbers that are in use in retrospective national bibliographies. With those two building blocks, we could present the end user with groups of records, all referring to the same imprint. After the latest system update, AMPL supports the option to publish data as linked open data with an API to go with that. And CERL is investigating further development work to implement this option for the various databases in AMPL. As noted before, preparing triples and offering the HPB as linked open data is also very much on our wish list. But with 9 million records and I don't know how many fields, that is actually quite a big undertaking. CERL has just proposed the implementation of a working group. This is today, we had a meeting this morning. The working group is looking at undertaking an organization-wide data modeling exercise and report on the best ways forward to create more data connections, do it efficiently, based on sound data structures, offering the best support for our standalone databases, but ultimately resulting in the best user experience. So it seems we have a fair bit of cross-collection to do in-house for ourselves, and therefore I'm very grateful to the previous speakers who've shown us the path of how we could achieve that or what is possible, and also to support us in our thinking that, for example, the CERL thesaurus can be a wonderful resource in backing up this new structure and making some of the connections for us. CERL is the custodian of some of the most important international resources for book research, which can function as key building blocks in the European data landscape. So it isn't just us internally doing cross-collection searching, but it's us, CERL, also creating the option and the possibility to slot into that European data landscape. CERL will work to tie in closer with this data network, because ultimately we will all benefit from new data connections that can thus be created. Thank you. So I'll ask myself, does anybody have questions? Is there one online? Don't know how I get to that. Yes, there we are. Is that a question thing? Okay, this was about seeing the presentation or not. Okay. If there are no questions online or in the room, then I would like to thank our hosts again for this wonderful start of the conference and invite you all to the next bit, which is going to be tomorrow morning with a presentation from the director here at the Széchényi Library and also the Sally Chambers from the British Library, who will talk to us a bit more about how Europe is supporting this data cloud and heritage data network. And then we'll have a short panel discussion, and then we'll have the directors meeting. So thank you all very much.
Thank you very much, Marianne, and thank you for your attention. And last but not least, we would like to invite you for a small reception in the next room. Okay, so thank you very much for being here, and hopefully see you tomorrow morning. Thank you very much. And thank you very much, yes, of course, thank you very much for the speakers. You were unbelievable, great. Thank you very much for being here, and hopefully see you somewhere personally in the future. Thank you very much once again. Thank you very much.